This video is the first video in the inferential statistics set of videos. In particular, in this video, we're going to look at types of distributions and the empirical rule. Now, inferential statistics refers to the branch of statistics that involves making predictions or generalizations about a population based on data collected from a sample. Unlike descriptive statistics, which focuses on summarizing and describing the data, remember our mean, our median, our mode, our range, interquartile range, and standard deviation, inferential statistics allows you to go beyond that data and draw conclusions about a larger group, mainly the population. So there's two main things that we'll be looking at when we're talking about inferential statistics, and that is the population and the sample. The population is the entire group you're interested in, for example, all students in Ireland, whereas a sample is basically a subset of the population chosen to represent the entire population. For example, if you wanted to figure out what percentage of the population supported Arsenal Football Club, what you might do is go around and get a sample of people from all around the country of different walks of life, different parts of the country, different occupations, and ask them, and then make an inference on the actual population, as it's impossible to ask the entire 5 million people that are in Ireland. When studying inferential statistics, we'll be looking at some of the key techniques used by statisticians. For example, we'll be looking at a hypothesis test, which determines whether there's enough evidence to support a specific claim about the population. For example, maybe by a politician when they say that they have 60% support, or for example by a skincare company when they say that 90% of people found that their product was effective. Statisticians are able to test those types of claims to see whether they're true or untrue. We'll also be looking at confidence intervals, the margins of error, and in this video in particular, we're going to look at the types of distributions we see and also the empirical rule. To begin, there are three types of distributions that you need to know. The first one is positive, the second negative, and the third is the normal distribution. The first type of distribution is a positive distribution or a right-skewed distribution. What this is it's when the data has a longer tail on the right side, indicating that there are more values on the lower end and fewer but larger values on the higher end. This type of distribution is shaped somewhat like your right foot, with the bulk of the data on the left and tapering tail on the right. Examples of positive distributions would be the age distribution of attendees at a pop concert such as Billie Eilish or Sabrina Carpenter, where most of the attendees are young, but there are a few older attendees, for example, parents of some of the attendees, or even just people who are older who like those particular types of artists. However, the most important thing to note is that at a Sabrina Carpenter or Billie Eilish concert, it's most likely going to be younger members there. It also might be the age distribution of people playing video games like Minecraft, where the majority are young, but some older individuals also play. What that means is that the majority of people who play Minecraft are young, particularly children, but you might have some people who are a little bit older who enjoy playing Minecraft as well. The second type of distribution we have is a negative distribution or a left-skewed distribution. Now, a negative or left-skewed distribution occurs when the data has a longer tail on the left side, meaning that there are more values on the higher end and fewer but smaller values on the lower end. This distribution resembles the shape of your left foot, with the bulk of the data on the right and a tail tapering on the left. This might be the age distribution of attendees at a classic rock concert such as Rod Stewart, where most of the attendees are older, but there are a few younger attendees. Another example of a left-skewed distribution might be the ages of listeners to Lyric FM on RTE, where the majority would be in their 60s or 70s. However, there might be one or two younger people who are listening, but for the most part, there we would have people who are older that will be listening to those types of radio stations. The last type of distribution that you need to know is the normal distribution. A normal distribution occurs when the data is symmetrically distributed around a central peak, with most values clustering around the mean and tails that taper off equally in both sides. This type of distribution is often referred to as a bell curve due to its shape. You've definitely heard of that word before in terms of junior cycle and leaving certificate grades. They're always graded on a bell curve, ensuring that students fit into the bell curve and that the bell curve doesn't change or move. The first example I have for a normal distribution is the exam results in standardized tests. Most of the students score around the average, with fewer students achieving very high or very low scores. So it's important to note that it's quite easy to pass most exams, but quite difficult to get a high grade or a grade that might be a H1. Another example that you might have is the heights of people in a population, such as in Ireland, where most individuals' heights are around the average, with fewer people being extremely tall or extremely short. Now, that doesn't mean that you're not going to bump into someone who's incredibly tall or incredibly small. However, it means that the majority of people in Ireland would be near the centre or near the average height. Over a period of time, statisticians realise that there's a very important relationship between the normal curve and standard deviations. I'm hoping that you can remember from the previous section on statistics that all standard deviation is it's a number that gives statisticians an indication of the distance the data is from the mean in a particular set of values. A low standard deviation means that most of the values are close to the mean, and a high standard deviation means that a lot of the values are far away from the mean. So for example, if you had the numbers 51, 52, 53, 50, 51, 54, 51, those numbers would have a low standard deviation because most of those numbers are all close together. However, if you had the data 1, 100, 5,000, 3, 7,900, those numbers are quite spread out, so there's large gaps between them, and that would have a high standard deviation because most of the data is spread out from the mean. The important relationship that was found is now referred to as the empirical rule, and the empirical rule states that the probability a value will be within one standard deviation of the mean is 68%. The probability that a value will be within 2 standard deviation of the mean is 95%, and the probability that a value will be within 3 standard deviation of the mean is 99.7%. Therefore, almost all the values will lie within 3 standard deviations of the mean if it is a normal distribution. The diagram that you can see on the page in front of you there is a normal distribution. So it has just a bell curve shape. We can see that the mean here is in the center, remembering that the mean is given by the symbol mu. We then have that within one standard deviation. So if you take the mean and you minus the standard deviation and you add a standard deviation, that 68% of the data is going to lie between those two values. If you minus 2 standard deviation from the mean and you plus 2 standard deviation from the mean, 95% of the data will lie between those two values there. And if you minus 3 standard deviations, so for example, if the standard deviation is 2 and you minus 2, you minus 2 and you minus 2, so you minus 6 in total, that would be the mean minus 3 standard deviations, and you get the mean and you add 3 standard deviations, 99.7% of the data will lie within that particular constraint. At the top of the page here, you can see the final 2 points of the empirical rule, that 95% of the data is within 2 standard deviations of the mean, and that 99.7% of the data is within 3 standard deviations of the mean. It's important to note that this only occurs, or the empirical rule only occurs, when it's a normal distribution, so when it has a bell-shaped curve. To ensure you understand how to complete questions involving the empirical rule, it's best to look at a few examples. Example 1.1 here, it says the average number of students absent from a secondary school per week follows a normal distribution with a standard deviation of 3.6. In 1 week, the average number of students absent was 18. What percentage of the population falls within the range 14.4 to 21.6 absences? The most important thing to note here is this is an empirical rule type of question if it tells you one particular thing. And the thing you're looking out for here is that it says that it is a normal distribution. Anytime that you see normal distribution, the alarm bell should be ringing and you should know that this is an empirical rule question. Anytime I suspect that it is an empirical rule question, I draw a normal curve. In the normal curve, we have the mean right at the center. The mean in this particular one is 18. There is 3 rules with the empirical rule. The first one is that 68% of data lies within plus or minus 1 standard deviation. The second one is that 95% of data lies within plus or minus 2 standard deviation. And the third one is that 99.7% of data lies within plus or minus 3 standard deviations. Mapping that out then, if we want to figure out where 68% of the population lies, we add 1 standard deviation to the mean and minus 1 standard deviation to the mean. 18 plus 3.6 will give us 21.6, and 18 minus 3.6 will give us 14.4. I hope that you can notice here that we're looking for the numbers 14.4 and 21.6. We've already calculated those by just adding 1 standard deviation to the mean and taking away 1 standard deviation from the mean. What that means is underneath the curve where I'm drawing in the blue, between 14.4 and 21.6, 68% of the data lies. Therefore, it says what percentage of the population falls within the range 14.4 to 21.6. So the answer for this question is 68% of the population. As 68% of the population will be between 21.6 and 14.4. To put that into context, what the question is talking about here is the average number of students absent from a secondary school per week. Therefore, 68% of the time, between 14.4 and 21.6 people are absent on average per week. If we wanted to add another standard deviation and take away another standard deviation, within that part of the curve, 95% of the population lies. So between whatever number would be here and whatever number would be here, those numbers would be 95% of the time a particular amount of student to a particular amount of student are absent in any given week. Now we'll go through a few more examples, but just to go back and clarify a few things. The empirical rule formula only applies to normal distributions. Therefore, you must be told in an exam if the distribution is normal. When you're reading a question in an exam and you see it saying a normal distribution, it's most likely going to be the empirical rule formula. For the empirical rule, there's 3 facts. The first one is that 68% of data lies within plus or minus 1 standard deviation, 95% lies within plus or minus 2 standard deviation, and plus or minus 3 standard deviation, we find 99.7% of the data. Example 1.2 says, the average time for students to solve a problem follows a normal distribution with a standard deviation of 2 minutes. On a particular day, the average time to solve the problem was 6 minutes. What percentage of students solved the problem within 2 to 10 minutes? In an exam, the reason why I would know this is an empirical rule question is because it has the key word that we look for every time, which is normal distribution. Anytime it talks about a normal distribution, it's most likely going to be an empirical rule question. To make this question as easy as possible to answer, the best thing to do is to draw a normal distribution. The mean is at the center of the normal distribution, and the mean here is 6. There's 3 facts that come along with the standard deviation. The first one is that we have 68% of data between plus or minus 1 standard deviation. We have 95% of data between plus or minus 2 standard deviations, and we have 99.7% of data between plus or minus 3 standard deviations. In this particular question, the standard deviation is 2. Adding 1 standard deviation will get 8, and minusing 1 standard deviation will get 4. The most important thing you do now is you look at the numbers in the question to the numbers that you've just written down. The numbers in the question are 2 and 10, and the numbers you've written down are 4 and 8. So they don't match yet. That means When the question says what percentage of students solve the problem, well, it's definitely not 68%. Again, we're going to minus another standard deviation and add another standard deviation. Minusing another standard deviation will be at 2. Adding another standard deviation will be at 10. Again, we check the question, and in the question it says what percentage of students solve the problem within 2 to 10 minutes. And if you see now, we have 2 and we have 10. What we've done is we started with the mean and we added 2 standard deviations and we took away 2 standard deviations. When we add and take 2 standard deviations, what we end up with is we end up with 95% of the population lying within that particular amount. Answering the question then, it says what percentage of students solve the problem within 2 to 10 minutes? The answer is 95%. In example 1.3, it says IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Isaac scored 132 on an IQ test. His friend Owen claims that Isaac's score is in the top 5% of all IQ scores, but Isaac believes that he is in the top 2.5%. Who is correct? Explain your reasoning. Again, the reason why I know this is an empirical rule question is because I see normally distributed. If you're unsure how to start this, the best thing to do is just to draw a normal distribution, and that's exactly what I'm going to do here. Now that I have my normal distribution drawn, I'm going to put where the mean is, and the mean is right in the center here. It says a mean of 100 and a standard deviation of 15. Again, I'm not too sure what this question is asking, so I'm just going to add my standard deviation and minus my standard deviation. Here I'll end up with 115 and I'll end up with 85. I'll minus and add my standard deviation again. I'll end up with 130 and 70. And finally, I'll do it one more time as I know it goes to 3 standard deviations. I'll end up with 145 and here I'll end up with 55. Again, the 3 rules, we have that 68% of data lies within plus or minus 1 standard deviation. 95% of data lies within plus or minus 2 standard deviations. And 99.7% lies within plus or minus 3 standard deviations. Reading the question again then, it says Isaac scored 132 on an IQ test. What I might do then is I might just place my 132 down here. So my 132 is between my 130 and my 145. It then says that his friend Owen claims that Isaac's score is in the top 5% of IQ scores, but Isaac believes that he is in the top 2.5%. Now, 132 is above 130, and 130 is in 2 standard deviations when they are added to 100. So the part that I'm colouring in here in green, this is 2 standard deviations. So between 70 and 130, 95% of the population lies. Meaning that either side will have 2.5% of the population, as the 2.5% will add together to give us the 5% that needs to be added together to give 100%. Therefore, the 132 is after the 130, meaning that it's in the top 2.5%. Therefore, Isaac is correct. And all I'm saying to back up my answer is to get the person to look at the diagram that I've drawn where I've applied the empirical rule. Now that we've looked at example 1.1 to 1.3, we've basically answered any type of question that could be asked in terms of the empirical rule. The important thing you need to know is the 3 different percentages, and you need to know when to spot an empirical rule question. To spot an empirical rule question, you're looking for the word normal distribution. You're looking for the word mean, and you're also looking for the word standard deviation. If you can understand example 1.1, 1.2 and 1.3, you should be able to do exercise 1 that goes with this booklet. And if you have any questions on any part of it, you just have to let me know and I'll help you go through it. That brings this video to an end.